Hi there and welcome to this video for Senior Physics on Electrostatics and Electricity. In this video we're going to explore the concepts of electric charge and how it basically works with respect to statics. Now basically electric charge is due to the idea that all atoms are made up of three constituent particles. We've got protons, we've got neutrons which are found in the nucleus, and then we've got electrons which are spinning around the outside. Now generally a build-up of electrons or protons will determine the charge. Remember, neutrons are neutral. So we can see that in this model that we've got here, we've got the protons and neutrons in the nucleus, and we've got electrons moving out on the in the orbitals. Now certain materials will have the ability, and certain atoms will have the ability to gain or lose electrons, thus becoming either negative or positively charged. We call this ionization. Electrical charge can often look at the movement of these electrons. Now electrons, as we know, are negatively charged and held in place by the interactive force of the protons in the nucleus. So we have this negative and positive charge causing an attraction. These, in normal cases, these charges are equal. However, as soon as an electron has been lost, then obviously we get an imbalance and we get a positive particle that's been, atom that's been generated, or likewise, if we have a extra electron added, we get an imbalance of electrons, so it becomes negatively charged. Now, electrons can be held either loosely or strongly depending on the type of atom that we're dealing with. Now, the principal concepts that we need to understand are these. Opposite charges attract to each other, so a positive and negative, or a negative and a positive, will attract. Likewise, if you can see in the diagram, we've got the positive ball joined to the negative ball, so they will come together. However, on the opposite side, like charges will repel each other, such a positive and a positive and a negative, they will actually push apart. There will be a force which will push them apart, and you can see that in the diagram that we've got on the right hand side there. Obviously the degree with which they push apart, the force can then be measured, and that force can then be utilized as a push, which likely is going to move objects around a circuit. Now this is very true when we look at something like a battery. Now if you look at a battery, we already know that we have a positive and negative end, but how is that set up? Now basically it's down to chemical oxidation and reduction, which causes an imbalance of electrons at one end. So as you can see here, what happens in a fully charged battery is we get a huge number of electrons which are pushed down to one end. We call that the negative end. The actual loss of electrons from the other end is called the positive end, or the positive terminal. Note that in this case there is no such thing as positivity. All positivity means is a deficiency in electrons. So to recap, we've got a huge number of electrons pushed down to one end due to the chemical reaction, and very few at the opposite end, causing a partially positive end. So as a result, what happens is we are going to get a huge amount of repulsion which is going to occur at the negative terminal. And that's very, very important when we're looking at the flow of current, which we will look at later in this course. Now what happens when we deal with a dead battery? We get the idea that the electrons are equally spaced. There is no ability for the reaction, the oxidation and reduction reaction, to push electrons to one end. As a result, the electrons are equally spaced, and as I said, nature likes it when it's equal, so there's no net movement, there's no net repulsion, so as a result there's going to be no net current, and the battery is classified as being dead. However, the electrons are still there. Now if you check out the YouTube clip on this link to this post, there's a very nice TEDx animation which shows how batteries work and how rechargeable batteries work as well. Very, very insightful, so do check that out. So we also can see that electrons can be removed from materials by the action of friction. For example, rubbing glass with silk. But you will have noticed this, for example, on a hot windy day. You go close to your car, what will happen is there'll be an imbalance of electrons and you'll get a tiny shock. Now, as I stated, by removing the electrons, an atom or a material will become positively charged. Likewise, if we move electrons onto it, they will become negatively charged. And as I stated, in nature, being equal is the name of the game, and this is true for charges. They want to move to an area where there are the same number of electrons on one side as there are on the other. Now, if there are more electrons on one object and less on another, they will move until both sides are equal. And if there's a good conduit which will allow them to move through it, for example a metal wire, will go from a negative terminal to a positive terminal. So the electrons will move through. We can then control the flow of those electrons using a resistor. Again, that's something that we will look at later on. However, let's go back to our car situation. If we have a large number of electrons built up on the car, or we've got a deficiency on the car and a lot on us, what will happen is the electrons from our hand will actually move towards the car to equalize it up. And we feel that loss of electrons in the form of energy, and as a result, it generates a small shock. And we can see shocks all over the place. For example, you take a woolen jumper off, and the result is electrons will be rubbed off and on to your skin. The electrons will try and move back onto the wool, and if you're in a dark room, and you can try this at home, if you take off the jumper, you can see tiny little sparks which are actually generated. And these are just due to the electrons trying to balance out. Where do we see this on a bigger scale? Well, it's going to be in lightning. You take clouds which are rubbing over each other all the time. What will happen is we will have a huge imbalance of electrons which are generated on the clouds. Whereas there are few electrons, well, it's going to be on Earth. And what happens is there is so much energy which is generated, and there is so much repulsion from the negative charges, that what wants to happen is the electric charge will flow down to Earth to equalize out. Now, we can look at the effect where materials can lose or gain electrons by looking at the Triboelectric series. Now, if you Google the Triboelectric series, you'll see something which is similar to the diagram that you've got on the right-hand side here. Notice at the top, we've got atoms which have a low affinity for electrons, i.e. they lose them very, very easily. And at the bottom, we've got atoms which have a high affinity for electrons. If a material is rubbed by something which is lower in the series, it will become positive because the object lower in the series will rub off the electrons onto it because it's got a high affinity. The one higher, the material higher, will lose it because it's got a low affinity, and as a result, the material lower will become negatively charged and the material higher will become positively charged. For example, glass can become positive when rubbed with a silk handkerchief, but negatively charged if rubbed with the rabbit fur. And you can see this is all down to the position of the materials relative to each other. Now, how can we test for this charge? Well, I've set up a simple practical for you to watch on this post on the Triboelectric series. So check that out, and that will explain and give you an idea as to how we could test whether something has been charged by another object. Note, it will not tell us the type of the charge that we've got there. We would have to work that out from the Triboelectric series. Well, let's have a little example as to how we can use the Triboelectric series. So from what I've gathered, from what I've explained earlier, I want you to use this question to help explain what's going on. What charge will the following rods become when rubbed with a silk cloth? So if I had a paraffin rod rubbed with a silk cloth, what charge would it be? An ebonite rubbed with a silk cloth, what charge will it be? Acetate and lead. So pause the video now and see if you can work out what charge they're likely to be, judging by their affinity for electrons and their position on the Triboelectric series based in relation to the silk cloth. So pause the video now and see what you can come back with. Hi, welcome back. So let's see how you got on. So let's look at the first one. The first one is the paraffin rod. So the paraffin rod, if we have a look, is going to be slightly below the silk. So it is going to take electrons from the silk and thus become negative. The ebonite is also below the silk. So it also will take electrons from the silk cloth, but it will probably take more electrons because it has a higher affinity. Now let's look at acetate. Now acetate is way above silk, so it will be positively charged. Lead is just above the silk, so it will be less positively charged, but according to the theory, it will be positively charged nonetheless. Okay, so I hope you found that useful. Check out the worksheets also on this post on electric charge and the Triboelectric series. Also, I put up another practical on how charge rods work with respect to water and an explanation behind how that works. Something really cool can be seen when you put a charge rod against a stream of water. Well, I hope you found this useful. I look forward to you joining me again. Thanks for watching.